Humans are natural pattern seekers. We look at a stranger in a tailored suit and assume they're an executive, or we watch a child glued to a screen and guess exactly how they'll act when we turn it off. Our brains draw rapid conclusions from everyday observations. This instinct comes with an inherent blind spot, confirmation bias. We cherry-pick evidence that supports our beliefs, ignoring contradictions. But if you rely on that gut feeling, you miss the entire picture, ending up with a reality that only exists in your head. There is a stark divide between casual observation and empirical reality. Stating that something is true requires a foundation of proof, not just a preconceived notion. To bridge that divide, we use the scientific method, a rigorous 5-step framework designed to pull our assumptions out of our heads and test them in the real world. The scientific method acts as a defense mechanism, a system built specifically to prevent our own brains from deceiving us. It starts with step 1, perceiving the question. Take the historical debate around children and media. For decades, parents and researchers have watched kids sit in front of the glow of the television and wondered what exactly is happening to their developing minds. The question here is specific. What is the measurable impact on a child's behavior when they are exposed to violent scenes on a screen? This leads directly to step 2, formulating the hypothesis. A hypothesis is a tentative, untested solution to the problem you've just perceived. In this scenario, we might formulate the following hypothesis. Exposure to violent television programming directly causes aggressive behavior in children. At this exact moment, that statement is nothing more than a structured belief. In reality, there is a high probability that it is factually wrong. And that is why defining a hypothesis is useless unless you subject it to a mechanism capable of proving it false.
We have to move from theory to physical action. That physical action is step 3, testing the hypothesis. To do this, we build the mechanics of an experiment. We take a pool of subjects and divide them into 2 tracks. Group A watches violent media, while Group B watches nonviolent media. Observing both groups under identical conditions neutralizes confirmation bias. We strip away noise to isolate how the television show alters behavior. Once the test is run, we reach step 4, drawing conclusions. Researchers take the aggregated data from the experiment and stack it side by side. They compare the average aggression levels of Group A directly against the aggression levels of Group B. This direct comparison provides the statistical evidence needed to definitively approve or disapprove the original hypothesis. This is the inflection point. Step 4 is exactly where a subjective belief is forced to become objective predictive data. But there is a final phase. Step 5 is reporting the research, the most critical yet frequently overlooked component of the entire process. Science relies on replication. If you lock your findings in a drawer, your study is scientifically invalid because the results can never be independently verified. Transparent reporting gives other scientists the exact blueprint of your work. It allows them to repeat the exact same experiment with an entirely new set of subjects, verifying that the outcome is a repeatable phenomenon. When we look at this panoramic view of the Martian landscape, it illustrates what we typically picture as hard empirical science. But the strict standards of evidence required to study planetary geology apply equally to the study of human behavior. Psychology requires the same empirical toolkit. It uses rigid experimentation and statistical correlation to map out the abstract complexities of the mind. Understanding these 5 steps gives you the power to interrogate the bold claims you encounter every day. By demanding to see the process, you can immediately separate a casual assumption from a verified truth.